We are now in Module 8C, and if you recall, in this whole set of modules, we've been working with systems of equations. Remember, a system means more than one equation. We've already seen we could have a system of linear equations with two variables, an x and a y. We saw we had a system of linear equations with three variables, an x, a y, and a z. And we saw when we solve, our answer is an ordered pair, a point, or an ordered triple, a point. And because they're linear, we have one solution for x, one solution for y, one solution for z. What we're going to do today in this last module is we're going to work with systems of nonlinear equations. And that means our exponents are not going to just be ones. They're going to be twos or threes, which guarantees us having more than one solution. So if our equation has an x squared in it, which reminds us of quadratics, we're going to have two solutions for x, which means we're going to have two solutions for y. The great thing about today is we're not going to be learning any new material. You're still going to have to either use substitution or the addition method to solve these systems. The difference, though, is you're going to have to make the decision now. They're not going to tell you which method. You're going to have to figure out which method's going to work best. So you have to understand how to do substitution, and you have to understand how to do the addition method. So let's go and see what kind of examples we have. Let's go to our notes. So if we look here, there's our definition. Nonlinear means the variable is to a power higher than 1. And to solve it, we're going to either use substitution or addition. The most important thing to realize is there's going to be more than one solution. So if we look here, I have 4 examples I'd like to work with you today on the whiteboard. If you look at all 4, they're not just all linear. They have x squareds and some have y squareds, which means they have powers higher than 1, which means we're going to have more than one solution. So if you look at our first equation, our first system, x plus y equals 2, and y equals x squared minus 4x plus 4, you'll notice the first equation's linear, x and y to the first power. But our second equation has an x squared, which means it's quadratic. And that means you're guaranteed to have more than one solution. So let's go up to the board and do our work. Okay, so here's your linear equation, here's your quadratic equation. We want to solve them. Now you have to make the decision. Which is easier to use, substitution or the addition method? So now you got to know the difference between the two. Let's think. Substitution means to replace a variable for what it equals. You know you can do substitution when a variable is isolated. Addition method means to have the equations lined up to add up all their like terms. Well, obviously, if you look at this system, it is quite obvious we're going to do substitution. We have y isolated. We know what y equals. Y equals this whole trinomial, x squared minus 4x plus 4. So what we're going to do is substitute. We're going to take this trinomial and put it in the spot for y. Now I know what you're thinking again. How can we replace one variable with 3? Well, it's just like in real life. If I have a dollar bill and I go to the soda machine and the soda machine's not taking it, I would exchange or substitute the dollar bill for 4 quarters. Even though physically they're not the same amount, $1 bill, 4 coins, they mean the same thing. And that's what we're doing here. We're replacing this one variable with what it represents. So now we're going to write our new equation. We're going to have x plus, but now we're not going to write the y. We're going to write x squared minus 4x plus 4, and it equals 2. Once you get back here, you are back to what you've already learned in all the previous modules. I'm asking you now to use your algebra skills. If you look, we have some like terms to collect. We also know we need to put this equation in the correct descending order. So x squared would go first. X minus 4x is negative 3x plus 4 equals 2. Now you've got to ask yourself, like you've been asking yourself all along, is my new equation linear, algebra 1, or is it quadratic, algebra 2? It's got the x squared, so it's quadratic. Well, now you got to remember, how do you solve a quadratic equation? You have 3 options. You either factor it, square root it, or use the formula. The formula to me is always your last resort. So I'm going to look at this and say, do I factor it or do I square root it? Normally we try to factor, but we have to know our process. To factor your quadratic, it must be set equal to, that's right, 0. So we move the 2. So we get x squared minus 3x plus 2 equals 0. Okay, now we're going to factor it. What's your rules of factoring? GCF, difference of perfect squares, trinomials. You've heard these over and over. What rule is this? 1, 2, 3, trinomial. 2 parentheses. What multiplies to x squared? X and x. What multiplies to 2? Well, that's only 1 and 2. Will 1 and 2 add to 3? Sure it will. To add means the same symbols. To add to a negative, they both got to be negative. Why do we factor a quadratic? To make 2 linear equations. So now we have 2 equations to solve. We set them equal to 0, and we solve each one. Our first solution is x is 1. Our second solution is x is 2. So far, so good? Great. Now here's the difference. Because we're dealing with a system, and this system has both x's and y's, we just don't want the answers for x. We also want the answers for y. So here we go, guys and gals. If there's 2 solutions for x, then there's going to be 2 solutions for y. If you know x, to get y, you have to pick one of the originals and substitute in. Now here's again where you get to make a decision. Which equation's easy to substitute into? The linear or the quadratic? Well, if you're with me, I think always working a linear equation is easier. So I'm going to write that linear equation. I'm going to write x plus y equals 2. X plus y equals 2. Because I got to take one x at a time and find the solution for y. So now I replace, I substitute. 1 plus y equals 2. I solve. I get y equals 1. Stop right there and write your ordered pair, your point. When x is 1, y is 1. Now let's go do the second solution. Using the same linear equation, now I'm going to use x is 2. 2 plus y equals 2. Subtract, y equals 0. So again, write your ordered pair. X is 2, y is 0. What this means is if we were going to draw a picture of these equations, they would not intersect in one spot, one point, they would intersect in 2 places. That's what you just found. The 2 x and y values that would balance both of these equations. How do we like that? Not bad, right? Using everything you've learned so far. All right, let's try our second example on the notes. So let me erase all this lovely work we just did. All right, our second set or systems is x minus y equals 1. X squared plus y squared equals 25. All right, it's a system. It's more than one equation. All right, we know we're going to want to solve for x and y. The first equation's linear. The second one's not linear. Now, you can't call this quadratic because it's not just an x squared, it also has a y squared. So it's just called a nonlinear equation. That guarantees we're going to have more than one solution for x. We're going to have at least 2. Now, this is tricky. When you first look at this visually, it looks like everybody's lined up ready to do the addition method. But you better pay attention. What does the word add mean from elementary school? Add means to put together things that are alike. You can only add apples with apples, bananas with bananas. So look, even though this is lined up, can you add the letter x to an x squared? Nope, they're not alike. Can you add a y to a y squared? No, they're not alike. Don't tell me that these are opposites. Y and y squared are not opposites. They're not going to cancel out. So even though that looks like the addition method, it is not. Now you're going to say to me, well, Miss Black, let's just make it the addition method. Let's change these to squares. Well, sweeties, you can't do that because it all goes back to an equation. An equation's got to balance. You can't put a square here and a square here and a square here. That would be 2 squares on the left, 1 square on the right. Now I know what you're thinking. You're thinking take x minus 1 equals 1, put 1 square on the left and 1 square on the right. I know what you're thinking. Well, again, that doesn't work because if you square this out, squaring means to write it twice. And if you multiply that out, that is FOIL. And if we did FOIL, x times x is x squared. X times negative y is negative xy. Negative y times x is negative xy. Negative y times negative y is positive y squared. And if you look closely, these terms in the middle are not going to cancel out and make 0. They're going to make negative 2xy. So by putting just 1 square on the left is not going to get you this to become x squared and this just to be y squared. You're going to have something else. So that's not going to work. Okay? I know what the second thought is. The second thought is going to be we'll take the equation at the bottom and to get rid of the squares, square root it. Again, we go through this. Think about it. You cannot square root and square root. Put 2 square roots on the left and 1 square root on the right. It won't balance. So again, I know what you're thinking. Put 1 square root on the left and 1 square root on the right. Well, it goes back to, can you square root when you have terms connected by addition? The only way to make sense out of that is to put numbers in. If I wrote you guys and gals the square root of 16 plus 9, and I said work that out, what would you do first? That's right. You have always been taught to do what's inside. You would add those first, get 25, and then square root it and get 5. You wouldn't separate it into 2 different square roots because watch, if you did separate it into 2 totally different square roots, square root of 16 is 4, the square root of 9 is 3, that makes 7. Does 5 equal 7? No. That proves to you that you can't take this apart. So you have no choice. You can't change the variables. You can't make the variables an x to an x squared or an x squared to an x. So we're stuck with those. What that tells you is the addition method is out. Even though they're lined up, they're not like terms. You can't do the addition method. So now you have to do substitution. Well, we have a problem, ladies and gentlemen. To do substitution, you must have a variable isolated. So again, you're in the driver's seat. Which variable is the quickest and easiest to isolate? Would it be working with the linear equation or the nonlinear? Yes, it would be the linear. So we're going to go down here first and we're going to isolate a variable. And you get to choose which variable to isolate. Do you want to isolate the x or the y? It doesn't matter to me, but pick the one that can be done quick and easy. It is very easy to isolate x. Because to isolate x, all you'd have to do is add y to both sides. And we get x equals y plus 1. Now we can do substitution. We could replace our letter x with y plus 1. We've already discussed this. We don't take the y plus 1 and go back to the equation we just worked. It goes into the other equation. So y plus 1 is going to go all the way there for x. Now we're going to rewrite this equation. Instead of using x, we're going to write y plus 1. So we have y plus 1, but then the whole thing is squared. Plus y squared equals 25. Now our algebra skills kick in. Squaring means to write it twice. To multiply a binomial times a binomial, we do our FOIL. So y times y is y squared. Y times 1 is 1y. 1 times y is 1y. 1 times 1 is 1. You know when you do FOIL, you're supposed to collect your like terms. We also have a y squared and the y squared, which happens to make 2y squared. Y plus y is 2y plus 1 equals 25. Now look very closely. Is that equation linear or quadratic? It has a square, it's quadratic. How do we solve quadratics? Well, I believe in factoring. It's always the quickest and easiest method. To factor it needs to be set equal to 0. So we subtract 25. 2y squared plus 2y minus 24 equals 0. We're going to do the rules of factoring. What's your first rule? That's right, it's GCF. What do they all have in common? I'm going to pull a 2 out. That's going to leave me y squared plus y minus 12 equals 0. Are we done factoring? No. There are 3 parts in here. It's a trinomial, so it will factor some more. So I put my 2 parentheses. Y squared is y times y. What multiplies to 12? 1 and 12, 2 and 6, 3 and 4. Do we go eeny, meeny, miny, mo? No, we say what multiplies to 12 and subtracts to 1. That would be 3 and 4. You said subtract. The signs have to be different. The sign in the middle goes to the larger. So the 4 gets the positive, the 3 gets the negative. The 2 that you pulled out stays in front. We've already discussed this in the previous modules. Every time you factor a quadratic, you make 2 linear equations. We have a y to the first and a y to the first. We're going to write 2 equations equal to 0. This 2 is useless now. You can go write an equation. You could write 2 equals 0. But do you have a variable to solve for? No. You took out that 2 to make it easier to factor. So now that it's useless because it doesn't have a variable, our 2 equations are y minus 3 equals 0, y plus 4 equals 0. We solve each. We add 3, y is 3. We subtract 4. We get y is 4. Y is negative 4. I'm sorry. Y is negative 4. So now you have 2 solutions for y. Are you guys done? No. Because this was a system, not only did we have y's, we had x's. So now we got to go find the solutions for x's. We just learned if there's 2 solutions for y, we got y is 3, y is negative 4. There are going to be 2 different answers for x's. Third time you're in the driver's seat. You get to choose which equation would be easier to go back and get the value of x. The linear or the nonlinear. Well, if you're like me, yes, the linear is easier. So I'm going to write it twice because I'm going to use it twice. I'm going to replace y with 3. So x minus 3 equals 1. I'm going to add x is 4. Before I ever go get the other solution, I'm going to write this as an ordered pair. Your x value goes first, it's 4. Your y value is 3. Now I'm going to go over here, I'm going to write x minus, what's y? Negative 4. 2 negatives make a positive. X plus 4 equals 1. Then I can solve. X equals negative 3. So now we can write our second order pair. The x value is negative 3. The y value is negative 4. Every stitch of work up here is review from previous modules. I did not ask you today in this last module to learn anything new. I asked you to use the stuff we've been already working on, all the concepts. Do not start making up your own little rules. This is a coincidence that these 2 answers are opposite each other. That's not always going to happen. Yes, we should have more than one solution because we had a square, but there's no guarantee they're going to be opposites. Okay, I'm going to erase all this lovely work. We're halfway done with this module. The reason why I'm working so many examples with you guys is because I want to make sure we review all this algebra that you have mastered. Okay, let's go to example 3. Our system is x squared minus y squared equals 5. X squared plus y squared equals 13. So we have a system. They're nonlinear because they're not to the first power. You can't call them quadratic because they're not just x squareds, they're also y squareds. All that tells you is you're guaranteed to have 2 or more solutions. If you look, again, this one looks like it's set up for the addition method. So let's discuss the addition method. You can only add terms that are what? Alike. X squared and x squared are alike. Good. Y squared and y squared are alike. Good. Numbers are alike. So I'm with you on this one. This one's ready to do the addition method. But we said with the addition method, you must make sure one of your terms Either the x's or the y's are additive inverses, or opposites. That will cancel out. Who's our opposite here? Very good, it's our y squareds. One is negative, one is positive. So we add that, it's going to make 0. It's going to cancel out. So we're ready just to do the addition method and add. X squared plus x squared is 2x squared. The y squareds are going to cancel out. 5 and 13 is 18. Now everybody look closely. That equation has an x squared. It's quadratic. You're in the driver's seat. Which method you want to use? Factor, square root, or the formula? Again, we don't use the formula unless it's our last resort. This time, guys, I'm going to look at this and say, you know what? This is easier to work with the square root method. Because the square root method, all you need is a square and numbers. Now, you have to know your process. When you do the square root method, you don't want the equation equal to 0. You want to move all the numbers to the right and then square root. So we said in our previous module, to do the square root method, you isolate who owns the square, and then you square root. So to isolate x squared, we're going to divide by 2. We're going to get x squared equals 9. The opposite of squaring is square rooting. You do it to both sides to keep balance. Squares and square roots cancel out. There's the x equals. We talked about this. When you square root, you must have 2 solutions, so you put your plus and minus. And what is the square root of 9? 3. That is saying there's 2 answers for x. X is 3. X is negative 3. So look, we're reusing something we've already learned in previous modules. Now, we have 2 solutions for x. We have to get 2 solutions for y. We go back to one of the originals. It doesn't matter which one you pick. I'm going to pick the bottom one because I like dealing with the plus sign versus the minus. So I'm going to write x squared plus y squared equals 13. X squared plus y squared equals 13. I'm going to replace x with 3. So this is 3 squared plus y squared equals 13. I'm going to square 3 and get 9. This is y squared. It's quadratic. I'm going to move the 9 over because I'm going to use the square root method again. It's quicker. Y squared equals 4. I'm going to square root both sides. Squares and square roots cancel out. Y equals. Don't forget you're square rooting to put your plus and minus. And the square root of 4 is 2. That's all review. Now I want you to notice something. You replaced x is 3. You used one number for x. You got out 2 numbers for y. So when you go to write this as an ordered pair, what was your x value? It was 3. You cannot write plus or minus 2 here. You're saying one of the 2's is positive, and when x was 3, one of the 2's is negative. So that alone made 2 ordered pairs. Plugging in one number for x got out 2 numbers for y. That makes 2 ordered pairs. Well, wait, we're not done. We haven't even dealt with the negative 3. So again, we're going to replace x with negative 3. We're going to write negative 3 squared. Now look at me. I'm a firm believer what you write, you better mean. This does not say take negative 3 and square it. If you're telling me to take this number and do it twice in my head, it's got to go in parentheses. Plus y squared equals 13. Now we'll work it. What's negative 3 squared? 9. 9 plus y squared equals 13. It's squared. It's a quadratic. I'm going to subtract 9 to isolate the square. I'm going to square root both sides and get y equals plus or minus the square root of 4 is 2. Now you're going to say, well, it's the same answer, but it's not. Because this time we didn't use 3, we used negative 3. So when x was negative 3, you got out 2 different y values. That makes 2 different points. So when x is negative 3, y can be positive 2. When x is negative 3, y can be negative 2. Now, I know what you're thinking. I've never drawn a picture of something that intersects in 4 places. You're right. When we go to draw this later on in the modules, this will not be lines. These will be curves, and curves can intersect in more than one spot. There are 4 points of intersection here. All 4 are the solution. If you replace the x and y and you work these equations, they will all work. So there's an example of doing a system and using square root method. All right, we got one more example to look at. Okay. Let's get our last one. So let me get my notes here. All right. Our last one is y squared minus x equals 4. X squared plus y squared equals 4. So the last time, we have two equations here. They're called a system. They are both not linear because they have squares. Now, you're totally in the driver's seat. You're the one making all the decisions. The directions do not help you. The directions just say solve. So again, you're going to look at this and decide, which method would you rather do here? Would you rather do substitution or the addition method? Well, addition means you need like terms. Okay, substitution means you need a variable isolated. Well, if I look closely at this, I have like terms y squareds, but an x and an x squared are not alike. So we talked about that. You can't make a variable change itself. So we don't have everybody being like terms. So I'm thinking let's do substitution. Now this is what I want to show you about substitution. Substitution means to replace something with what it equals. I know that you guys have been programmed to, when you do substitution, get x by itself or y by itself. But guys, look closely. What variable do both of these equations have in common? They both have a y squared. So if you were going to do substitution here, that's the variable you would want to isolate. You would want to know what y squared equaled. And if you take the top equation and you isolate y squared, you could have that done in one step. So when you do substitution, it doesn't mean to get x by itself or y by itself. It means to get any variable by itself. Because both these equations have a y squared in common, that would be the variable that I isolated. So I'd add x here, and I would get y squared equals x plus 4. That means when I see my y squared, I'm going to replace it with x plus 4. Don't go back to this original. You've already worked with it. Go back here. That's what we're going to replace. So our new equation is going to be x squared plus, I'm not replacing y. What am I replacing? Y squared. So all of that is gone, and it's going to get the x plus 4, and it equals 4. If you look, I got an x squared. It's quadratic. My goal is I'm going to get it set equal to 0, so I'm going to subtract 4 here. X squared plus x, that cancels. That cancels equals 0. What way can we solve this equation? You have to do factoring. You can't do the square root method because that's not a number, it's a letter. You can't move a letter to the right and square root it. So we're going to factor doing GCF. They have in common an x. That would leave us with x plus 1 because x squared divided by x is x. X divided by x is 1. Every time you factor, you make two linear equations. The first one solved, x is 0. The second one we subtracted 1. Are we done? No. We got to go back and get y. Again, it doesn't matter if you use the first original or the second. Doesn't matter to me. I'm going to use the first one. So I'm going to write y squared minus x equals 4. Y squared minus x equals 4. I'm going to replace my 0. Y squared minus 0 equals 4. Well, that means there's nothing there. So this is y squared equals 4. It's a square. I could square root a number. So now I get y equals plus or minus. The square root of 4 is 2. Again, notice, you used one number for x. You used 0. You got out two numbers for y. So this is two ordered pairs. 0, 2, 0, negative 2. But we're not done. We had another answer for x. We had x is negative 1. So we're going to write y squared minus, we're going to replace x with negative 1, equals 4. Two negatives make a positive. So I'll move the 1 over by subtracting. I'll get y squared equals 3. I'll do the square root method. I'm going to do it up here now. I have y squared equals 3. I square root both sides. Y equals, because squares and square roots cancel. I always put my plus and minus. Can you square root the number 3? No, 3 is prime. It has no perfect square. We've already reviewed that. So we leave it as a square root. You got two values for y when you just use this x is -1. So again, two more ordered pairs. When x is -1, you get at a positive square root of 3. When x was -1, you get at a negative square root of 3. Everybody's with me? Great. So in this last module we did for module 8, all we learned is that we can solve systems. We use all these algebra skills we've been building on, and we only have two methods. Sometimes the addition method works well, sometimes the substitution method works well. We have both of them. That's why it's up to you to decide which method's easier. Have a great day.